Welcome to this presentation discussing the multiple linear regression prediction algorithm. Multiple linear regression is one of the most popular methods used for prediction today. This method fits a linear model between an output variable, y, and a set of features, x1, x2, all the way to xn, where the following holds true. Y equals b0 plus b1 x1 plus b2 x2 plus b3 x3 all the way to bn xn plus e, where the b's are the coefficients and the e is the noise or error in the model. The data is used to estimate the coefficient values and the variability of the error. This is the Boston housing dataset, which is another well-known dataset collected from the U.S. Census in 1978. Each row or record in the dataset contains housing data from a census tract in the Boston area. You can think of a census tract as a zip code, so each row or record in this dataset contains average housing data from within a geographical area. Each column is associated with a feature, such as the per capita crime rate by tract, the proximity of the tract to the Charles River, the average number of rooms per dwelling in each tract, etc. First, we'll randomly partition the data using percentages of 60-40, where 60% of the records randomly allocated to the training set and 40% of the records randomly allocated to the validation set. I'm going to include all of my variables in my partition data. I'm going to leave pickup rows randomly selected under partitioning options. And I'm going to leave automatic selected under partitioning percentages when picking up rows randomly, along with the default values of 60 and 40. If I want to see the 304 rows allocated to the training data, I simply click this link. If I want to see the 202 rows allocated to the validation data, I simply click this link. Now we're ready to run our prediction method. My output variable is going to be my MEDV variable, and this stands for median value. The rest of my variables, except cat MEDV, will be used as my input variables. Cat MEDV is a categorical variable based on the MEDV variable, so we're going to leave this variable out of the prediction method. Click Next. I'm going to select Best Subset, and I'm going to ask for both detailed reports and lift charts for each set. Here are our results. We have our output navigator at the top, our input selections, and let's scroll down. So here we see our regression model. Here we have our coefficient value, standard error, p-value, and sum-of-squared error for each of our variables, along with summary statistics off to the right. Let's scroll down a little bit to the best subset selection. So here we see subsets of our full model. Let's take a look at this first subset that includes two features, a constant term and the LSTAT variable. This subset has a residual sum-of-squared value of 11,527. Now, as we add features, the residual sum-of-squared error is going to decrease. So let's take a look with the subset with 12 features. This subset has a residual sum-of-squared error of 6,978. Now, if I click Choose Subset, I'm able to run a second multiple linear regression with these 12 features. Now we see our summary reports. As you can see in the training data, our average error was 3.11 e to the negative 7, which is essentially 0. And in our validation set, our average error was negative 0.011, which is also a very small value. Now we can look at our detailed report. Here we see our predicted value, our actual value, and our residual value for each of our records. This is for our training data, and this is for our validation data set. Click the Training Lift Chart link. The lift chart compares the multiple linear regression model's performance against a model with no predictors, meaning that the baseline is simply an average of the y's. Since the lift curve is higher than the baseline, we can say that our model's predicted performance is better than the baseline model. The decile chart shows the factor by which the model outperforms the baseline model, taking one decile at a time. So, out of the top 10% of the census tracts with the highest predicted median selling prices, The model performs almost twice as well as the baseline model. Clicking the MLR Valid Lift Chart 1 worksheet shows the same type of information for the validation set. Now let's run our model on new data. So to do so, we're going to click Score. We're going to choose the correct worksheet, confirm the data range is correct, and choose the MLR Stored 1 sheet, which is where our model has been stored. Now we can click Next. We're going to match variables with the same name in each set and click OK. And here are our results. So let's take a look at this first record. Here, this housing price has a predicted value of $26,000 based on the features of this house. Keep in mind, these housing prices are dated from 1978. So you could multiply these by probably about 100 to get the current year's pricing. Prediction methods can be used to predict raw material needs, future sales, staffing needs, etc. This concludes this presentation on XLMiner's multiple linear regression prediction algorithm. To speak to our technical support staff, click the link that appears on the screen now.